All right, now let's write the Python code for finding the insert position of a particular target value in a sorted array of values that we have been given using binary searching algorithm that we have discussed previously. So here I have created the class and created the function, and I have written the code for calling that specific function as well, so that we can complete this implementation quickly. Right now inside the function whatever we have defined, right, let me just define couple of variables. Start with 0, and will be the last index that we have on the array, which is nothing but length of the array minus 1. Now along with that I will also define one variable middle. Now using binary searching algorithm we will simply run as long as start is less than or equal to n. What we will do, we will calculate the middle. Middle is nothing but we will simply do math.floor, right, since we will get floating point numbers here. For that let's just import math. Okay, so here let's do math.floor of start plus end divided by 2. Okay, and once we get the middle, now if at all the value of this target is already available inside this array at this middle index, then we can insert that specific value at that particular index, right? So we can simply return that middle itself. So if at all the value we have in the middle is equal to the target that we have been given, in this case we will simply return middle itself. Okay, if this is not the case, obviously the other scenarios are the value in the middle is greater than the target and the value in the middle is smaller than lesser than target. So here let's just write, if at all the value we have on the middle is greater than the value we have got inside the target, in that case what we need to do, we need to search the insert position somewhere on the left part of the array, because the value we have on the middle is already greater than target that we have given. So here to continue that searching logic, we will simply update end with middle minus 1. If this is not the case, obviously the other scenario is where the value we have on the middle is smaller than target, so it can be inserted anywhere on the right part, right? So here what we will do, we will simply update start with middle plus 1. Okay, here I need to return middle, I forgot to type D, that's why we are getting. Now ultimately, as we have discussed inside our algorithmic approach, we have decided that once we complete this while loop, whatever the value we have inside this start variable will basically represent the appropriate position at which that value can be inserted, right? That's why here we will simply return the value we have inside the start. That's it. That is the simplest solution of finding the insert position of a particular target value inside the sorted array, such that the array will still remain sorted. One more thing that you need to remember here is, whatever the array that we have got is sorted in the ascending order. That's why I have written this logic. If at all if your array is sorted in the descending order, you just need to write the appropriate code for that, just by interchanging this logic here. Anyway, here we have the array sorted in the ascending order containing values 1 2 3 4 5 6, and the target is 5. So I want to insert this 5 inside this array such that it will be sorted after that as well. Now if you see here, the value of 5 is already available, right? It is available at index 0 1 2 3 4. So obviously the output should be something like 4. If you see here, we have got the output also as 4. Let's just say, for example, there is no 4 5 in the array. The array itself has 1 2 3 6. Now 5 can be inserted before 6, right? That before 6 is nothing but 0 1 2 3. At index 3 we can insert 5 such that it will be sorted. So if I run this code now, see the output that we have got is 3. Okay, likewise, let's just say the input array that we have got is empty, there are no values at all. Now I want to insert this 5. So if I run this code right now, obviously at index 0 we can insert 5, right? Because the input array itself is empty right now. So if I look at this now, see the output is 0. Okay, so basically it is working most of the scenarios. Let's just say I want to insert minus 5 right now. Now minus 5 will go before 1. 1 is already available at index 0, right? So minus 5 should be inserted at index 0. So if I run this right now, the output should be 0 again. We can insert minus 5 at index 0 such that the array will still remain sorted. Okay, so that is how we solve the, finding a appropriate insert position of a particular target value inside a sorted array using binary searching algorithm effectively. Okay,